The next thing that we need to talk about is charge. If you wanted to know the charge of an atom, you could use this little formula to figure it out. It's the number of protons minus the number of electrons. Okay? But I'm not going to use this one all that much because I think there's a better way to think about this. Okay? The better way to think about charge is to say that it's the overall charge of an atom based on whether there's an abundance of either electrons or protons. Okay? And that should make more sense when you see a couple of examples of it. So first of all, why does charge only have to do with protons and electrons? Okay? Notice in this case, the definition has nothing to do with one of the particles, except for this time, it doesn't have anything to do with neutrons. Okay? And that's because if you look at the charges of these particles here, a proton has a positive 1 charge, an electron has a negative 1 charge, and a neutron is neutral. What that means is that neutrons do not contribute at all to the overall charge of an atom. So to demonstrate this, I'm going to use these two examples here. Okay, here's a representation of an atom where we've got 1 proton, 1 neutron, and 1 electron. This one's got 2 neutrons, 1 proton, and 2 electrons. Okay? So I was saying that mathematically you could figure out the charge just using this formula right here. And that will work to figure out the charge. But the way I think about this is that it's just the overall charge of the atom. Okay? And it makes sense if you think about this information right here. Every time you have a proton, it's got a charge of positive 1. Okay? So I'm going to put a little +1 right next to this proton right here. What it says is that every neutron has 0 charge. So I'm just going to write nothing down next to the neutron. The electron has a negative 1 charge. Okay? So I'm just going to put a negative 1 beside that. Okay? So just think about this mathematically. You've got a positive 1 and a negative 1. Okay? A positive 1 would exactly cancel out a negative 1. So the overall charge of these guys would be 0. So let's take a look at this one right here. This guy is a proton, which means he's got a +1 charge. Each one of the electrons has got a -1 charge. So one way that you can think about this is 1 proton will exactly cancel out 1 electron. And your charge is just going to be a matter of which do you have more of? Do you have more electrons than protons or more protons than electrons? So in this case, I'm just going to say this guy would cancel out this guy, okay, and that's because a positive 1 is going to directly cancel out a negative 1, and what you're going to be left over with is a negative 1. Okay, so let's do a couple of examples. So for this example, we've got 1, 2, 3, 4 protons, 1, 2, 3, 4 neutrons, and 1, 2, 3, 4 electrons. Okay, so first of all, atomic number. Remember that the atomic number is simply the number of protons that are in the nucleus. Okay, so you're going to look up here and say 1, 2, 3, 4 protons. That means the atomic number is 4. Okay, mass number is the sum of both the protons and the neutrons. So we've got 1, 2, 3, 4 protons plus 1, 2, 3, 4 neutrons. That's a total of 8. And finally, let's do the charge. The way I do this is just to cancel out 1 electron for every proton that you see, and then just to count up how much left over you have. Okay? So we could say that this cancels out with this cancels out with this cancels out with this, and this cancels out with this. Okay? In this particular case, every single proton exactly cancels out with exactly 1 electron. What that means is that the charge is 0. Okay? There would be 4 positive 1 charges in the middle, and then 4 negative 1 charges due to the electrons. Mathematically, +4 plus a -4 equals 0. That's why the charge is 0. Okay, so let's try this atom right here. So for the atomic number, it's just the number of protons. 1, 2, 3, 4. The mass number is going to be the sum of the protons and the neutrons. 1, 2, 3, 4 protons plus 1, 2, 3, 4, 5 neutrons. That gives a mass number of 9. Okay? And to figure out the charge, you want to figure out whether there's an excess of either protons or electrons. Okay, well, this proton would cancel out with this electron. This proton would cancel out with that electron. So what do you have left over? Do we have leftover protons or electrons? Okay, we've got leftover protons here. Each proton has got a charge of positive 1. So if we've got two things left over that have a positive 1 charge, the total charge on this entire atom would be positive 2. Okay? And remember, when you're doing charge, if it's a positive charge, you need to include the sign. Even though mathematically plus 2 is the same as 2 without the plus written in front of it, you need to have that sign to indicate that it's positive. Okay, and so one last example. This time there are 1, 2, 3, 4, 5, 6, 7 protons, 1, 2, 3, 4, 5, 6, 7 neutrons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Okay? So atomic number, 1, 2, 3, 4, 5, 6, 7 protons. Okay? The mass number, 7 protons, 7 neutrons. That's going to be 14. The charge, you got to figure out which there's more of, protons or electrons. Okay? So this cancels out with this cancels out with this cancels out with this with this with this with this with this, and we've crossed out all the protons here. We've got 1, 2, 3 electrons that weren't crossed off. Okay? Each one of those has got a negative 1 charge. Okay? So if you add up all of that charge, you've got a total of negative 3. What that means is that this entire atom here would have a charge of minus 3. Okay? And that charge is due to the fact that it had more electrons than it had protons. So far we've gone about solving these problems by using a picture. We've drawn a representation of an atom that's shown the protons, the neutrons, and the electrons, and we've calculated atomic number, mass number, and charge based on that picture. But just keep in mind that there's a different way the information could be presented. It could be just presented as giving you the number of protons, neutrons, and electrons, but you should still be able to figure out what this information is based on this. So let's do a couple of examples. So this just says that you've got an atom that's got 9 protons, 10 neutrons, and 10 electrons. Okay, so we should be able to calculate all this information here. So atomic number, it's just the number of protons. Okay, so the atomic number is just going to be whatever this is right here. Okay, mass number, that's the number of protons plus neutrons. So you just take 9 plus 10. That gives you 19. Charge has to do with the relative numbers of protons and electrons, because each one of these has got a plus 1 charge. Each one of these has got a minus 1 charge. So the one that you have more of is what's going to determine what the overall charge of the atom is. So when calculating charge, I think it helps to think about it visually. Okay? So remember that for every proton you have, it's going to cancel out with an electron. So that once you've canceled out all the particles, whatever you have left over is going to determine what the overall charge of the atom is. So what I've done here is just drawn out 9 circles representing the 9 protons that are in the atom. At the bottom here, I've drawn out 10 red circles representing the 10 electrons. Okay? So what I'm going to do here is just say, for every proton, I'm going to cancel an electron out. Okay? So we're just going to continue that procedure. That guy would cancel with that guy. This guy cancels here. Okay, and then you get to the end. This guy would cancel with this guy. And then you just want to take note of what's left over. Okay, we've got 1 more electron than you do protons. Since this guy has a negative 1 charge, that would mean the overall charge that the atom has is going to be negative 1. Okay, so it might seem obvious to some of you that it's not necessary to draw out these circles if you can do it mathematically. Just by looking at these two numbers here, you can tell that the electrons outnumber the protons by 1, which means you're going to have one extra of these, and you could use that information to determine that your charge is going to be a -1. It doesn't matter to me which way you figure this out. If drawing out the individual particles and canceling out each individual one helps you, that's fine. But if it's just as easy for you to look at these numbers and calculate the charge, that's also fine. The last little bit of information that this asks for is the element, okay? And to do this, you're going to be using the periodic table, okay? If you open up your reference guide to the middle, you're going to have a periodic table that looks something like this, okay? The way to figure out the element is to realize that the atomic number of the element is found at the top of the box for that element, okay? So if you wanted to know what element is this atom, all you would have to do is say it's got an atomic number of 9, take a look at the periodic table, find the square that's got the 9 at the top, and you'd see that that element is fluorine. Okay, let's try one more example. 20 protons, 21 neutrons, 18 electrons. The atomic number is just the number of protons. Mass number is going to be protons plus neutrons. That's going to be 41. Charge, you need to look at the relative number of protons and electrons. Which do you have more of? We've got 2 more protons than we have electrons. Okay, what that means is that the atom is not only going to have a positive charge, it's going to have a positive 2 charge because the protons outnumber the electrons by 2. And so if you needed to know which element this is, you go to the periodic table, take a look at the one whose atomic number is 20. That's going to be calcium. Okay, so if you can go in one direction, you should be able to go in the other direction. So let's try this example right here. We've got an atom whose atomic number is 47. Its mass number is 108. Its charge is 0. Okay, we should be able to fill in the rest of the information here. So, what element is this? Take a look at the periodic table, find the one whose atomic number is 47. You would see that that's silver. Okay, so how do we figure out how many protons there are? It's going to be the same as the atomic number. So that's going to be 47. Figuring out the number of neutrons requires a little bit of logic. Remember that the atomic number is the number of protons. The mass number is the number of protons plus neutrons. Okay? So, how would you figure out the number of neutrons given this information? Okay? Well, before, we would take this number plus the number of neutrons in order to get this number. So if you're working in reverse, what you're going to do is take this number, subtract this number away, and that should tell you how many neutrons you have. And that's going to be 61. And you can check to make sure that that answer is correct, because if this is right, then this number plus this number should be this. That's what we were doing before. Okay? So 47 plus 61 is going to give you 108, which is the mass number. Okay, charge is 0. Okay, remember what charge comes from. You're going to have a charge if there's either more protons than electrons or more electrons than protons. When you've got exactly 0 charge, that means that there's exactly the same number of protons than electrons. So if we know that there's 47 protons, that means that there has to be exactly 47 electrons.